Hello, welcome back guys. Today we are going to be considering Physics Jjamb 2010 solution. Physics Jjamb 2010 solution, and today we have paper type B before us, and the first question says, which physics question paper type is given to you? Which physics question paper type is given to you? As you can see here, there is paper type B on my old question paper, and here is physics question paper type odd B, and the option here is what? Option B. So let's take the word option B as what? As my correct answer. Now, second question says two cars moving in the same directions have speed of 10 km per hour and what? And 130 km per hour. What is the velocity of the faster car as measured by an observer in the slower car? Now, as you can see here, we are told that two cars moving in the same direction of speed 100 km per hour and what? And 130 km per hour. We can see what is the velocity of the faster car as measured by an observer in the slower what? Car. Now, as you can see here, we have two cars moving in the same direction. Assuming now we have two cars moving in the same direction. Let's take this to be our car. Now, another car. They are moving in the same direction, and we are told that what? They are both moving in the same direction, but their speed are different. We are told that the what? The speed of the first car have what? 100 kilometer per hour. Now the next one, the second car has what? 130 kilometer per hour. Now, what is the what? Velocity of the faster car as measured by an observer in the slower car? Now, this is what? A relative what? Velocity. We have to calculate the relative of the faster car which is moving at what? The one that is moving at 130 km per hour to the what? To the one that is moving at 100 km per hour, because they were asked that what is the velocity of the faster car as measured by the observer in the slower car. So we are measuring the relative velocity with respect to the what? To the faster car. So which is what? The car what? B here. We have car B here. We have car what? A. So we are measuring the relative velocity with respect to what? B. So therefore we have what? We have velocity B minus velocity what? A. That's how to calculate the relative velocity of what? Of A and B. Now with reference to what? B, which is what? The faster car. So this is 130 minus what? 100. So the answer here is what? 30 km per hour. 30 km per hour. This is 30 km per hour. So here, option here we have option what? D to be our answer, 30 km per hour. Now, the diagram given to us, here is the diagram given to us, and we are told that the diagram shows a velocity time graph. As you can see, this velocity, this is what? Time. The diagram will show a velocity time graph. The statement that is true about this what? Motion is that the car decelerates between point F and H, accelerates between point F and H, has a constant speed between point E, and has no acceleration between point F and G. Now let's go to the diagram given to us, the velocity time graph diagram given to us. You can see that this place, it represents what? It can say that this line starts from a point what? E, and it has a slopey what? Line from point E to F, that is a gradient line, meaning that what? This is an acceleration. We have acceleration A here. So the body is accelerating at point E to point what? F. The car starts with acceleration at point E to point F. Now here we have F and G. Now at this point F here we have uniform velocity. We call it uniform what? Velocity. This is a uniform velocity. I will represent it with uniform velocity. While No, E to F is acceleration and F to G is what? Uniform velocity. Why what? Why the G to H here is deceleration, also known as what? Deceleration also known as what? Minus A, or is often known as what? Minus A. Deceleration, or sometimes called what? Retardation. So it can be called deceleration, it can be called what? Retardation. So now this is the level of what? Of the diagram, and we are told that the statement that is true above this motion is that deceleration between F and H. F and H, where is F and H? There's no deceleration between F and H. F and H, there's no connection to them. Now, accelerate between F and G. There's no acceleration here. We only see what? A uniform velocity, that a constant what? A uniform velocity, that is a constant velocity. Now, as a constant speed between E, no. As no acceleration between point F and G. Yes, there's no acceleration here. There's no acceleration. Whenever we have uniform velocity here, in a what? Whenever you have uniform velocity, A is equal to what? 0. You can see whenever there's an acceleration here, we have a gradient. But whenever there is what? Uniform velocity, A is equal to 0. And now this is what? A equal to minus what? A equal to minus at this end here. So at uniform velocity, which is U, A will be equal to 0. So that's why at what? At F and G, between F and G, there is no what? Acceleration. As no acceleration between what? Point F and G. There is no acceleration between point F and G because there is a uniform velocity. They can maintain a constant what? Velocity, because acceleration can be defined as what? As change in velocity. Please note that acceleration is defined as change in velocity. I'm using U now. Change in velocity with what? Change in velocity with respect to what? Time. Now, but we are told that there's no change in velocity. So meaning that what? Your A will be equal to 0. So there's no change in velocity, 0 over what? dt. Definitely A is equal to 0. So that's why we said there is no acceleration between F and what? G. No acceleration. A equal to what? 0. So that's option what? Option D. So let's go to another next question. A stone and a feather dropped from the same height above the Earth's surface. A stone and a feather. A stone and a feather. A stone and a feather. A feather can be like this. Was dropped, a feather and a stone was dropped from a what? From the same height. From the same height. So dropped from the same height. From the same height above the Earth's surface. Ignoring here resistance. Note the word ignoring. Ignoring here resistance. Which of the following is correct? Now, a stone and a feather was dropped from above the Earth's surface, and we are told that we should ignore the here resistance. Which of the following is correct? Now, when you throw a stone and a feather, ignoring the here resistance, both the stone and the feather will what? Hit the ground because here has been what? Has been removed. So let's see which statement is correct. Which of the following is correct? Now, the stone and the feather will both reach the ground at the same time. This is very, very correct. Because there is absence of air resistance, there is no external force that is affecting them. So they both fall under gravity at the same time. So regardless of the mass. So the stone and the feather will both reach the ground at the same time, regardless of the what? Of the mass. You can see that what? The mass of a stone is heavier than the what? Than the feather, but under the same circumstances where there is no what? Air resistance, they will both what? Reach the ground at what? The same time. This is what was postulated by Galileo, and it was confirmed by what? By Isaac Newton, that there is a presence of what? When there is absence of air, they both fall down under the what? Influence of gravity at the same time. So the option here is option A. The option here is option A. Now, question number 5 here says the surface of a conveyor belt are made rough so as to A. Prevent the road from slipping, B. Make them stronger, C. Enable them to carry more load, D. Protect them while carrying load. Now, when you see something, the surface here, you note the word surface here and rough. Now, friction occurs between surfaces that are rough. Now, we are told that the surface of the conveyor are made rough. That is, the surface of the conveyor belt are made in such a way that friction will be encouraged, because the surface of the conveyor belt are rough. So they are what? They are made in such a way that friction will be encouraged between the surfaces of the conveyor belt. So what they are trying to do by making the surface of the conveyor rough is to encourage friction, which prevent the load from slipping off. Because when there is no friction, there is a constant motion. There is a motion that is that will occur. So friction tends to oppose motion. So that's why, to prevent the load from slipping off, we encourage they encourage the use of surfaces of conveyor belt to be made rough. So the option here is option A. Now, it was used, the surface of the conveyor belt is made rough or are made rough to prevent the slipping off of load. Option A. Please take note of that. Now, number 5 here says that a car moving with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? Now, a car moves with initial velocity, so we are given the initial velocity u. Initial velocity u is equal to 25 meters per second. Then, and it reaches a final velocity of v equal to 45 meters per second. So now we are told that this velocity was attained in 10 seconds. Now, what is the acceleration? Now, from the formula of acceleration is given as change in v over t. So meaning that v minus the final velocity minus initial velocity all over t. So we're having now what's the final velocity? The final velocity is 45 minus now the initial velocity, which is 5 all over 10. So we are having our acceleration to be equal to now 45 minus 25 is going to give us 20 over 10. So acceleration is equal to Acceleration is equal to 20 over 10, which is 2 meters per second squared. So this is final answer, 2 meters per second squared. We have it option D as well. So now an object is weighed at different locations. An object is weighed at different location on the earth. What will be the right observation? Both the mass and the weight varies. No. The weight is constant while the mass varies. No. The mass is constant. Now mass is constant regardless of regardless of the place where you are taking the measurements. Now mass is constant regardless the location of your measurement. Why weight varies? Why? Weight varies due to to the presence of gravitational force. So the mass is constant, is not affected by by gravity. So but the weight is affected by gravity, because weight itself is equal to mass times acceleration due to gravity. But mass is a standard or fundamental unit, which is constant regardless the location of your measurement. So the mass is constant and weight varies due to the gravity, acceleration due to gravity. So the answer here is C. The right observation is that the mass is constant while the weight varies as a result of what? Acceleration due to what? Gravity. Number question 8, which said the diagram above represent balls in an undulating surface. You can see this an undulating surface is not a stable surface. An undulating surface is in a form of sinusoidal or curve. Which of the following options represent the position of a stable equilibrium? Now, which of the following options is stable equilibrium? This is not stable enough. This is not stable. You can see at this point here, we have a stable what? Equilibrium. So, from what we got 3, 6, and 9 has a stable what? Equilibrium. So now let's consider, do you have any option like that? We have got 3, 6, and 9 has what? A stable equilibrium. As you can see, they are undisturbed here because they are in a what? In a position of what? Of rest. So that's why we have a stable what? Equilibrium. Now, question number 9 says a bulb of weight 0.1 Newton hangs from a massless what? Massless string of length. So a bulb of weight 0.1 Newton is hanged from a massless what? String of length 50 cm. A variable horizontal force which increases from 0 is applied to pull the bulb until the string makes the angle of 60 degrees. Supposed to be 60 degree, 60 then degree with the vertical. The work done is dash. Now we're talking about what? A ball of weight W, which is what? 0.1 Newton, is hung on a what? On a length what? On a massless string with length 50 cm. This is not a standard unit. So you have to take it to a standard unit by dividing it to what? By 100. So the length has a SI unit of meter. So you have to take it from centimeter to meter. So 50 divided by 100 is going to be what? 0.5 meter. Now that's the what? Ideal unit of measuring length. So now a variable string makes an angle of what? 60 degree when what? When displaced by a force. That is a variable horizontal force which increases from 0 is applied to pull the what? To pull the bulb until the string make an angle of 60 degrees. So now, for instance, now if you have a pendulum bulb attached to a what? To a retor stand. Now, initially it is in this position of rest. Now we are told that that mass of this what? The weight of this is 0.1 and the length here is what? The length here is 0.5 meter, while the weight is what? Is 0.1 Newton. Now, after the displacement, we are told that this makes an angle of what? Of 60 degree. 60 degree. This makes an angle of 60 degree. Now, make an angle of 60 degree. What is now the work done? Now, as you can see here, that this is the length, this is the what? This is the weight. So, work done here is given, and this weight is work done is given as W. Let me represent this weight with what? Force, because weight is a form of what? Force. Weight is a form of force. So, weight is a type of force. So, weight can be called also force. So, since I'm using work done for W now, work done is equal to what? Now, the force multiplied by the distance, which is the length of what? Force multiplied by the distance, that is the perpendicular distance, cos the angle. Now, this one is having an angle, so we have weight work done is equal to force times what? Distance cos theta. That is the formula for calculating what? Work done that has an angle, of an object that has an angle. So meaning that what? F multiplied by L cos what? 60 what? Degree. Because our angle is 60 degrees. So substituting now, we have W equal to what? What's the F? F is 0.1 times 0.5. Now, 0.5 times cos 60 is also what? 0.5. Cos 60 is also 0.5. When you press cos 60 on your calculator, is 0.5. So now W is equal to, now you have 0.5 times 0.5, that should be what? 0.25. Multiplied by 0.1, that will be 0.025. So 0.025, that is the answer. 0.025. Then the unit of what? Of work done is what? Is in joule. So that's that about that. So question number 10 says a machine of velocity ratio 6 requires an effort of what? Of 400 Newton to raise a load of 800 Newton through 1 meter. Find the efficiency of the machine. Now we are told that a machine with a velocity ratio, a machine with a velocity ratio of 6, and then 400 Newton of effort was used to raise a load of 800 Newton through 1 meter. Find the efficiency of a machine. Now, efficiency of a machine is expressed in percentage. Efficiency of a machine is expressed in percentage. So it is given as what? Percentage, then what? The symbol what? E. So it means that the efficiency of a machine is what? Is expressed in percentage. So the efficiency of a machine is equal to what? Is equal to MA, that is the mechanical advantage, over what? The velocity what? Ratio multiplied by 100, based on the information given to us, because the efficiency of a machine can be calculated using different what? Using different formula, and one of the formula is what? Mechanical advantage over what? Velocity ratio times 100. You see, also have what? Output over input times 100. That's another formula for calculating efficiency. So, but as far as this question is concerned, we are given the velocity ratio of what? Of 6. So this velocity ratio of what? Of 6. We are given what? We are given the effort. Effort used to raise a load is what? Is 400 what? Newton. Then we are given also the load itself. The weight of the load itself is 800 what? Newton. Now, before you can apply this formula, you must first get your what? Mechanical advantage. Because the velocity ratio has been given directly, but we are not given what? The mechanical advantage. So mechanical advantage can be obtained using what? The formula. The mechanical advantage can be obtained using the formula. Mechanical advantage MA, using the formula load over what? Effort. This is the formula for calculating what? Mechanical advantage. Load over effort, which is what? 800 Newton. 800 Newton all over what? 400 what? Newton, which is the effort. So 400 here 1, 400 here we have what? 2. So we have here to be what? 2. No unit, because Newton cancel Newton. So we now come back to this place now and calculate our percentage E, so which is our efficiency. So but our efficiency is equal to over what? 6, which is our what? 2 is our what? Mechanical advantage, all over what? 6, which is velocity ratio, times what? 100. So it will give you what? 2 here 1, 2 here 3. So 3 here 1, 3 here is what? 3 here is 33.3. So we have 33.3%. So the percentage the efficiency is what? 33.3. So that's 33.3 for you. So now the answer here is 33.3. Please note that this is 33.3%. So the option here is option C. So that's that in question number 10. So we have come to the end of the lesson for today. Please remember to subscribe so that you can see the remainder of the solutions under this Jjamb past questions. See you next time.